Area 2. Okay, so last time we learned about area for squares and rectangles. Let's take a look at areas for some triangles and circles. Okay, last time we learned about one versus two dimensions. One dimension tells us we're measuring a distance. Two dimension, distance or length. Two dimensions tells us we are measuring how much space a flat thing takes up. So flat space. Yeah, that works. Flat space. Okay. Triangles are the next easiest shape to learn. So let's take a look at, there's not really a good way to make triangles in this app. So let me just make a, okay. So here's a triangle right here. Just look at this half. So we want to know how many tiny squares are inside of this. Let's start by just measuring the sides again. So this side we have something, and this side we have something. I'll pause to count. So we have a 6 by 7, and remember, always remember units. 6 units, 7 units. We have a 6 unit by 7 unit triangle, but we also have this side. But remember, two dimensions means they're at perpendicular angles to each other, which means a right angle. So we already have that right here. So we've already measured the two things we need to. But if we take a look, this triangle we have is inside of a bigger rectangle. So first, let's calculate the area of this rectangle. This rectangle is 6 units by 7 units. 6 units by 7 units gives us 42 and the u squared, 42 units squared. And if we counted all those little squares inside of it, we'd actually get the same thing. Now, what about the triangle? Well, if we notice, this triangle is exactly half of this rectangle. And we can see that if we flip it around, this triangle is exactly the same as this triangle. It's just flipped upside down. And let's see if we can do that. If I can flip it. See, they're exactly the same. So that tells us that for the area of a triangle, all we got to do is divide this area of a rectangle by 2. So 42 becomes 21, 2 becomes 1. We're left with 21 units squared. And that's all there is to it. So for a triangle, all we got to do is find the right angle, measure the two sides, multiply them, and then divide by 2. So the way we write that, so area of a square, let me write that formula. Area of a rectangle, actually. Hold on. There's customers, I gotta go. So the area of a square or a rectangle is going to be the base times the height is one way of writing it. Another way we can say it is the length times the height. Another way we can say it is base times length, whatever. The point is we're just multiplying the two sides that meet at a right angle. Now for a triangle, the area of a triangle is 1/2 base times height. So, or whichever other way you want to write it. But the point is half of a square. Now, this is using, let's do some substitution for this, for example. So, oh, is this in this view? Oh, I got a little restart. Okay, we're good. Okay, so let's use substitution. So the 1/2 is a coefficient, so that doesn't change. Our base is going to be our 7 up there, so we'll do 7 units. And our height is going to be 6 units. So if we multiply that out, we get 1/2 times 42u squared, and then we can cancel again, and we're still left with 21 units squared. Now, another thing we can do, remember our commutative property? That tells us that we can do multiplication in any order we want. So let's back up to right here. So as long as we're multiplying, we can change the order that we do it in. So instead of doing 7 times 6 times u, let's go ahead and flip it. 1/2 times 6u times 7u. And now we can cut our 6 in half, because 6 times 1/2 gives us 3, and now we're just left with 3 times 7, which gives us 21u squared. And this is similar to what I teach y'all with the fractions. Remember, we want to reduce before we multiply. Since these are all being multiplied, we can treat this as 7 over 1, this is 6 over 1, and we can say what factors are in common with the top and the bottom. 6 and 2 both have a 2, that becomes 3, that becomes 1, and we can skip right to the end. So the point of this is sometimes you can take shortcuts when we're multiplying for area of a triangle, because we can use this 1/2 to cut one of our sides in half. Because it's easier to do 3 times 7 than it is to do 6 times 7 divided by 2. That's the point. Okay, next we have circles. Circles are special because let's take a look at what happens if we try to count all the squares in the middle. So we do have all these big ones right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. But besides that, all these other squares are cut off. And they're not cut off with straight lines, so it's very difficult. So let's introduce let's talk about a few more things about circles before we continue. So circles have a few main points. They have one called the radius, and the radius is the center of the circle to the outside of the circle. That's called the radius. The the diameter is all the way across, going through the middle. So we got radius equals center to edge. We've got diameter, which equals 2 radiuses, because we have one radius here and the other here. They just get added together. We have the outside of a circle, this part, that's called the circumference, which is the measure of the outside of the circle itself. Circumference is that, I think it's a F, PH? I think it's a PH. No, it's an F. Ference, which is the measure of the outside of the circle. So let's talk about how we measure the radius. Is pretty easy. You just need a straight line, and we already know how to do that. But this outside, the circumference, we don't know how to measure as easily. Luckily, we have a tool called pi, which will help us with that. So through a lot of measurement and calculation, the Greeks or the Romans or whoever were able to find out that if you multiply, it's not funny. Sorry, my mom is laughing at me.
The Greeks are bad.
She doesn't know much about math.
Okay. Archimedes.
No, you did triangles. Alright. I lost my frame. Okay. Okay. What is the 2 pi? Okay, so to get the measure around of the circumference, we got 2 ways we can do it. We can do circumference equals 2 times the radius times pi, and I'll explain what pi is in a second. Or since we know that 2r equals the diameter, like it is right here, another way we can write it is diameter times pi. Now pi is a number, and it's a special number, and we derive it by saying that's what we have to multiply the diameter to get the circumference. So pi is a rational number, and I think I explained that in our real videos. I might not have. Oh yeah, irrational means you can't turn it into a fraction even if you wanted to. But it's 3.1415 ... and it goes on forever and ever, and it keeps changing, and we never know what the next number is going to be. But for our purposes, we'll just use 3.14. So let's say we wanted to calculate, let's say our radius is 3, and we want to know the circumference. Well, let's do substitution. Circumference equals 2r pi. Use substitution. 2 doesn't change. R is 3. Keep our units. And pi equals 3.14. If we multiply all that, we get something. Please hold. 18.84. But remember, we do also have our units in there, so we got to bring those along too. 18.84 units. Now, we can learn more about circles later, but that's pretty much the gist of it. Let's learn the area now. So, area of a circle equals pi r squared. So, let's take the circle we were already working with. Its radius was 3, so let's do substitution. Pi equals 3.14. Our radius equals 3 units, and we're going to square it. So using PEMDAS, we got exponents. So we got 3. This, how do we say this in English? 3u multiplied by itself twice. So let's take a look at that. 3u times 3u. We got 3 times 3 is 9. We got u times u, which is u squared. So bring everything down. 3.14 times 9u squared. And then we just need to multiply our coefficients, which will give us, please hold, 28.26 units squared. So if we go back to our original circle, if we tried to count all these up, we would get probably about 21 full circles, and then all the smaller circles would combine to get the rest of our area. That's about it for now. This should give you an overview. Work on some practice problems. Ask me questions if you need it. Okay, bye.